Okay, our lesson today is going to be entitled Factoring. We're going to be working on factoring. And we're going to back up just a little bit and review what factors are. From middle school, you learned that factors are the numbers that you can multiply together to get a product. So what are the factors of 3? 1 and 3. What are the factors of 6? 2, 3, 1, and 6. Okay. Then we also did something else with factors we called prime factors. We made factor trees. Do you remember that? Okay, so we made a list of the factors of 3 and the factors of 6, and we found that the greatest common factor is 3. That's the one that they have in common. The highest number factor that they have in common. Thumbs up if you remember this. Okay, well, we're starting there at this basic to review that really what we're going into now is not a whole lot different. We're going to list the factors of 3a squared. In other words, what does it take to get a 3a squared? Well, it takes a 3 times an a times an a. Correct? Okay, what did it take to get a 6a? Right, 6 times 8. Now, can I break 6 down? I could be a 1, a 2, a 3. I mean, those are my factors of 6, and I could list it such. Let's try to do like a factor tree for it. It would be 2 times 3 times a. Okay, so what do we have in common? We have a 3, and 3 is the greatest common factor of 3 and 6. We just proved that up here. And then what else do they have in common? 1a. So we could say that the greatest common factor of 3a squared and 6a is 3a. And I kind of like to look at this as, you know, what do they have in common? What can I pull out of each? If I had to divide this term by something and this one by the same amount, what would that amount be? I could divide them both by a 3a. I could get a 3a out of both of them. Does that make sense? Okay, next I want you to factor 12g to the second, h to the fourth, and we're going to think factor tree. Now, I'm not finding the greatest common factor yet. I'm just kind of breaking this one down. So when I think factor tree, think of the prime factorization of 12. What do you get? Okay, 6 and 2, and 6 is it prime? No, you get 2 times 3. Okay, so what's my prime factorization here? 2 to the second times 3 times, now let's break down the g and the h. G times G times H times H times H times H. Okay, that is broken down in factor form. Now the reason we do this is because we try to find common factors when you have more than one term. Okay, any questions on this? All right, now let's apply that principle to finding the greatest common factor of those two terms, 4x squared and 24x to the third. So break 4x squared down. What do I have? 2 to the second power times x times x. All right, and here I have what? Okay, 12 times 2, which I could still break down into 6 times 2. And 2 times 3, so I get 2 to the third power times 3 times x times x times x. Now you'll get in the habit eventually, well, you'll just think of this as 2 to the second power x to the second. And here you'll have 2 to the third times 3 times x to the third. Okay, and you won't have to write them all out. Now, what do they have in common? They have 2's. How many 2's do we have in common? I don't have 5 in common. This one has 2. Does this one have at least 2? Okay, so I could take 2 2's away from that. I could divide them both, so I'd have 2 to the second. And then how many x's do they both have? I mean, I could take out of both of them. Only 2 to the second power, so it'd be x to the second power. So we say that 4 x squared is the greatest common factor of those two terms, because I could divide them both by a 4x squared. Can I divide 4x squared divided by a 4x squared? And I get 1. Can I take 24x to the third divided by 4x squared? Yes, and I still have something left over, but that's called the greatest common factor. Okay, we are finding the greatest common factor of those two terms. Let's say that I was trying to find the greatest common factor of 4x squared and 24x. What would be the greatest common factor of those two? I could get a 4 out of both of them, but how many x's can I get out of both of them? Just 1. So we say then that 4x is the greatest common factor of those two terms. Okay, your turn. We're going to factor 4x to the third minus 30x squared. Now, I'm putting them together in a problem now. So I have to look at those two terms and say, what can I take out of them? Write that down. When you think you have what their greatest common factor is that I would be taking out, and you write that down, raise your hand, I'll come check you, and then you can check your partner. So you ask yourself, what can I take out of both these? What can I divide them both by? Can I divide them both by 4? No, it doesn't quite work. Okay, so does 2 work? All right, so I can get a 2. Now let's take a look at your x's. X to what power could I get out of both of them? To the second. All right, so now let's actually then factor this. So this was my common factor. It's out there by itself, correct? What would be left if I did divide this by 2x squared? You'd have a 2x. Okay, now what would happen to this term if I divided it by 2x squared? Well, think, negative 30 divided by 2 is negative 15. X to the second divided by x to the second is x to the second divided by x to the second is 1. So there's nothing. So then you have factored it already. 2x squared times the quantity 2x minus 15. I don't have anything else out here. Okay, and that is what you call factoring. All right, let's try this problem. This is example B, let's say. I want you to factor 5x squared plus 20x to the fifth. Factor it. So in other words, you have to find the greatest common factor and then take it times what you have left. Okay, it looks like most of you got the greatest common factor. You were able to pick out that 5x to the second was the common factor of those two terms. Now, we're going to go ahead and factor that out of this quantity, these two terms. When I take 5x squared divided by 5x squared, what's left? 1. Any number divided by itself is 1. Okay, so then plus, what's 20x to the fifth divided by 5x squared? 4x to the third. So this is the process called factoring. Okay, if they give you a polynomial and they ask you to factor, they're asking you to try to pull out common factors and then rewrite it. Now, sometimes what we'll do, when our last chapter, we started here and then we distributed to get a polynomial. Okay, now we're working backwards. We have polynomials. We're trying to find greatest common factors or common factors to then break them apart again. Make sense? Hopefully.